So sequences are a progression of numbers. Okay. And usually they follow a particular pattern, but they don't necessarily have to. They could be totally random. So let's look at these 3 different examples of sequences. So we have 1, 2, and 3. So this first one, at the beginning, we have 1 dot, and then after a minute we have 3, and then after 2 minutes we have 9, and then after 3 minutes we have 9, 18, 27. So what we want to do is write down the terms as a sequence. So it starts with 1, and then moves on to 3, then 9, and then what was the last one? 27. 1, 3, 9, 27. How do you think we'd find the next term? What's the pattern here that we're using? How do we get from 1 to 3? What did we do? Multiplied by 3. How do you get from 3 to 9? Multiplied by 3 again, right? So what do you think we're going to do to find the next term? Yeah, we multiply the last term by 3. Okay. Now let's look at this one. So here at the beginning, the very beginning, we have, let's see how much are in each one of these little clusters. Yeah, there's 10. So how many is there total? 40. And then after a minute, how many do we have? 20. And then what? 10. So write these terms as a sequence. 40, then 20, then 10. So how would we find the next term? Divide by what? By 10. What do we do? How do we get from 40 to 20? Divide by what? 2. 2. Yeah, 2. And then how do we get from 20 to 10? Think about it. If we split 20 in half, how much would be in each half? If I had $20 and I wanted to share it with Maricia and Sharon, how much would each of them get if I split it equally? 10, right? Yeah, 20 divided by 2 is 10. Yeah, so how are we going to find the next term in this sequence? What do we have to do? Yeah, divide 10 by 2. Divide the last term by 2. Okay, now the last one. So we've got 3 in the beginning. And then how many do we have after a minute? 6. And then 12. And then 24. So we went from 3 to 6 to 12 to 24. How are we going to find the next term? Multiply by what? 2. 2. Right. Now let's talk about, so these are sequences. These are all examples of sequences. And actually, these are all examples of geometric sequences. So remembering what we talked about yesterday, what is a geometric sequence? It's a specific type of sequence, a sequence where each term is found by multiplying the previous term by a common ratio. What is our common ratio? Common ratio is the number that is multiplied by each term in order to find the next term. So I just said that geometric sequences are sequences where terms are found by multiplying each term by a common ratio. And I said that these three sequences we just looked at are all geometric sequences. However, in the second one, we weren't multiplying by a number, were we? We were dividing, right? However, if we want to, so let's say we have 40 and we want to divide by 2. That's the same thing. That's the same thing as saying 40 times 1 over 2. 20 divided by 2 is the same as 20 times 1 over 2. So we still have a common ratio here. We're still really multiplying. Okay. So let's look at this problem at the bottom, the swing situation. So Samantha's dad gives her a push on a swing, and at her highest point, she's 5 feet off the ground. If he does not give her another push, each progressive swing will be 85% of the height of the previous swing. So how would we find the height of the next 3 swings? And how would we figure out what the height would be after the 10th swing? So we looked at one similar to this yesterday. So first piece is we need to recognize our starting point. Our starting point is right here. It's at 5 feet. So our first term of the sequence is 5. Now our common ratio is right here in that 85%. How do we write 85% as a decimal? Yeah, 0.85. So if we want to find 85% of 5 feet, we need to multiply 5 times 0.85. And now for the next swing, for the third swing, we take our previous term, which is this, 5 times 0.85, and again we multiply it by 85%. Right? And then the same thing will happen here. We take our previous term, 5 times 0.85 times 0.85, and then we multiply it again by 85%. So let's simplify this a little bit so we can better see the pattern. So this is going to be 5 times 0.85, and there's just one 0.85, so that's just to the 1 power, to the first power. How could I rewrite this for the third term using exponents? Yeah, it'd be 0.85 squared. Yeah, good. Good. We saw that yesterday. Okay, and now for the fourth term, we have 5 times 0.85. And now what power is it raised to? The third. Okay. So, what do you recognize about the relationship between our exponents and our term numbers? What's the relationship? For the second term, we raised it to the first power. For the third term, we raised it to the second power. For the fourth term, we raised it to the third power. What's the difference? Or what's the relationship? Yeah, 1, 2, 3, 2, 3, 4. So our term number is 1 greater than the power number. So when we go to write an equation for the 10th term, so going to follow the same pattern, we're going to say 5 times 0.85 to what power? So for the second term, we raise it to the first. For the third term, we raised it to the second. For the fourth term, we raised it to the third. So for the 10th term, what would we raise it to? Ninth. Yeah, the ninth, because it's 1 less. The power is 1 less than the term. I'm going to raise it to the 9th power. Let's go over to the back page. Okay, so we're looking at these 3 sequences again. We looked at those on the first page too, where the first one is 1, 3, 9, 27. So what was our common ratio? What did we multiply each number by to get to the next? What did we multiply it by? Yeah, that one's 3. We multiplied it by 3. So our common ratio is 3. And what was our next term? You can use your calculator if you want. You might know. 81. Yeah, 81. It's just 27, our last term, times our common ratio. Okay, what about this one? So remember, we divided it by 2. We divided it by 2. How do we write that? Whoa, hello. So we divided by 2. What did I say that was the same as if we want to use multiplication? If I don't want to write this as a multiplication problem, what do I multiply by? Not 10. Not by 40. Remember this? So what do I have to multiply by for it to be the same thing as dividing by 2? 1/2, 1 over 2. 1 over 2. So I multiply this by 1/2. Okay. So my common ratio is going to be 1 over 2, 1/2. And then what would my next term be? If I divide 10 by 2, or if I multiply 10 by 1/2. What's my next term going to be? 5. 5. All right, and then this one, what was I multiplying by here? By 2. So my common ratio is 2. And what's my next term? 48. So we're looking at geometric sequences, how to find the next term. There's 2 steps here. So first we want to find the common ratio by dividing a term in the sequence by its previous term. And then we want to multiply that common ratio by the term at the end of this sequence and continue until we have the desired amount of terms. So we first find our common ratio. What is our common ratio? We find that by dividing a term in the sequence by its preceding term, so the term behind it. So I take 108 and I divide it by 324. 108 by 324. So what's 108 divided by 324? Yeah, or it's, can we write it as a fraction? 1/3. So that's our common ratio. So now, step 2, we multiply the term at the end by our common ratio. So 36 times 1/3 gives us what? Gives us 12. And now 12 times 1/3 gives us what? 12 times 1/3, 4. Okay. So same thing over here. First we find our common ratio. Find the common ratio by taking one term and dividing it by the previous term. So that would be -15 over -3, which equals what? 5. So now, the next 3 terms in the sequence, well, we're going to take our last term and multiply it by the common ratio. So what does negative 75 times 5 give us? Negative 375. And then what's going to be our next term? We multiply it by 5. So multiply negative 375 by 5.
Negative 1,875.
Yep, negative 1875. And how do we find the next term? You multiply again, which gives us what?
Negative 9,075.
Thank you, Jasmine. You are the calculator wizard today. Okay. So just found our next terms. Now let's look at finding the nth term. So that's looking for some term way out in the future. So this is our formula for finding the nth term. This first term here is the nth term in the sequence. A1, that's going to be our first number in the sequence. And then R down here is our common ratio. And then n minus 1 is going to be the position in the sequence that we're looking for. So when we are being asked to find, so like when we had that swing problem or when we looked at that bungee jumping problem yesterday, it asked us to find the swinging height after 10 swings, or the bungee jumping, the rope stretch after, I don't remember how many bounces, 10 bounces, I think. So same thing here. Assuming that the geometric sequence continues, what is the height of a bouncing ball on the 9th bounce? So we're trying to find the nth term. In this case, it's the 9th term. So what we want to do is, step 1 is find our common ratio. Again, by dividing a term in the sequence by its preceding term. And then we substitute our given values and the common ratio into our equation. So let's first find our common ratio. That's our R. So that's going to be 1.8. 1.8 over 3. We divide one term by its preceding term. 1.8 over 3 gives us 0.6. 0.6. Now A1 is our first number in the sequence. First number in the sequence. Our first number in this sequence is 3. That's our A1. And then N is the number of the term that we're looking for. We're looking for what the height is after the 9th bounce. So 9 is our term that we're looking for. So that's going to be N. And then we use our formula to find the nth term, to find A9. So we replace n with 9. We place A1 with 3. And we replace R with 0.6. So let's do that. So AN, that's going to be A9, right? Because 9n equals 9. So A9, the 9th term, equals A1, which is 3, our first term, times R, which is 0.6, raised to the n minus 1 power. So n is 9, so it's going to be raised to the 9 minus 1. So let's just rewrite that. That becomes 3 times 0.6 to the 9 minus 1, that's 8. So to the 8th power. We can put that into our calculator. We get 3 times 0.6 raised to the 8th. That gives us 0.504. Let's look at this one. So now we have similar, except for this time we're looking at bacteria. So assuming that this geometric series sequence continues, how many bacteria will be in the culture at the end of 7 hours? So we first need to find our values for each variable in the formula. So A1, that's going to be our first term in the sequence. Our first term is right here, it's 250. N is the term that we're looking for. So our terms are like our different hours. So first hour, second hour, third hour. We're looking for the 7th hour. So 7 is going to be N. And then R, we have to figure out. We figure it out by taking one term. So let's take 1,000. Take one term and we divide it by the previous term. So that's 1,000 over 500. 1,000 over 500, which is 2. So now we have our 3 variables, and we can plug them into our formula. So AN, that's going to be A7 this time, equals A1, which is 250, equals 250 times R, which is 2, raised to the n minus 1. Well, n is 7, so it's going to be 7 minus 1. So this comes out to be 250 times 2 to the 6th. Let's use our parentheses still. Oops. And then again, we can plug that into the calculator. Does everyone know how to use the exponents in the calculator? Let's go through it real quick. So in the Desmos calculator, which is what I prefer that you use, not that one, desmos.com/scientific. So I'm going to plug this in. I'm going to do 250 times, then I do open parentheses, 2, close parentheses, and then there's this button right here. It says A to the B. A to the B. See it? Yeah? Okay. A to the B, and then the cursor just moves up into the superscript, and then we plug in 6. And that gives us our answer, 16,000. So there's going to be 16,000 bacteria after 7 hours. Okay.